Okay, here are the conic section notes. This is page 4. We're going to talk about hyperbolas. So over on the left-hand side, you notice this equation looks a whole lot like the formula for ellipses. It's just got a minus instead of plus. Okay. Now, the note underneath says x and y's are interchangeable. We are looking for the positive variable, so the one that's not being subtracted, tells which way we open. So a hyperbola is basically an ellipse that's turned inside out. So let's take a look at what we got here. This one is going to be centered at the origin. So if you notice, this also has to be set equal to 1. I'm going to go ahead and divide everything by 144. So I get x squared over 16 minus y squared over 9 equals 1. Notice in the equation those denominators are written as something squared. So I've got x squared over 4 squared minus y squared over 3 squared. That equals 1. Okay. Now, I am going to start the way we did with ellipses. I've got x squared over 4. I've got x minus 0, y minus 0, so I know my center is at the point 0, 0. That hk is going to be our 0, 0. Notice in this example, we're at 0, 0. X is over 4, so I'm going 4 to the left, 4 to the right. My y is over 3, y squared over 3 squared. So I'm going 3 up and 3 down. And here's how we're going to use this just a little differently. I am going to draw this imaginary box. Okay, horizontal through my y values, vertical through my left values. That is going to give me the asymptotes. So we've identified the center. Let me see if I can color code here. Foci, we're going to wait a minute. Vertices we've got, but all 4 of those points are not vertices. And I want the asymptotes. My asymptotes are going to go directly through the corners of this imaginary box. Both directions. When we're centered at the origin, pretty easy to find those equations. From this point to the corner, I'll go up 3 over 4. So my asymptotes are y equals, the slope is 3 over 4x, and the negative, I add down 3 over 4, y equals negative 3 over 4x. My vertices, because my x is positive, right here, I got the x squared over 4 squared. I'm subtracting off. My vertices are along the x-axis. And they are going to curve and open towards our asymptotes. The transverse axis is the axis that the hyperbola is opening along. Okay. The vertices we found, the foci here are just a little different. So if we take a look down here, the foci are found this way: c squared equals a squared plus b squared. So here, my a squared, 4 squared, my b squared is 3 squared. And we can solve for c. Along the transverse axis, so this is going to be negative 5, 0 and positive 5, 0. My foci do not help to graph. Just know that any point on the hyperbola is going to be at a constant difference between the two foci. So we'll find the difference between the further away focus, and we'll subtract the difference between the closer focus, and it is always going to be the same. Okay? Now, I will tell you, the asymptotes are always change in y over change in x. Doesn't really matter which way this is opening. So the slope, and we've got that going in the positive and negative direction. I will be honest and tell you that this next example, you will not have to do for the final. Everything we have on the final is centered at 0, 0. Okay, but so we have a reminder, and so we look at this a different way. I'm going to collect my y's, and I'm going to collect my x's, and I'm going to be very careful to put that negative out in front, because I know it's a hyperbola. I got a y squared minus x squared, which means I've got to change the sign on my 4x. I'm factoring out the 4. I don't know why that happened. I'm adding 9 to this side. So I've got to add 9 to the other side. Oops, no I don't. I've got to add 9 times 4. Scratch that momentarily. Now sometimes you say things and you know they're wrong. The 36 came from multiplying that 9 times 4. I added a 9 inside the parentheses. That entire set of parentheses is getting multiplied by 4. So minus, I got x squared minus 4x. Half of that is negative 2. Squared is 4. Keep in mind here, I didn't add 4. I subtracted 4 because I got that minus out front. I get 4 times y plus 3 quantity squared minus x minus 2 quantity squared equals 4. I divide everything by 4, and I'm going to write that step out. These cancel. I got y plus 3 squared over 1 squared minus x minus 2 squared over 2 squared equals 1. So my center here, x is still 2, y is negative 3. It doesn't matter if y is coming first. The adjustment to the x is 2, the adjustment to the y is -3. So my center is at 2, -3. And now same thing, I am going to draw the little box. So my y value has a 1 underneath, so 1 up, 1 down. My x has a 2 squared underneath, so 2 to the left, 2 to the right. Having trouble seeing my, which means my asymptotes now again, we can find the equations for these asymptotes. That is not something you will be asked to do on the final exam. Okay. Y is first, so that means that I'm opening up along a vertical axis and down. My transverse axis, this line right here, the line x equals 2. My vertices, this point here, 2, -2, and 2, -4. And that's really all we need to worry about. We can use, if we're given the focus, we can use the formula c squared equals a squared plus b squared to find either a missing a or a missing b. It's not really necessary to graph. Notice that when the y squared term is positive, it opens up and down, and if the x squared term is positive, it opens left, right.